Lesson 1.3 focuses on modeling with linear equations, and basically what that means is applications. So they use the word modeling because they use that in the sense of showing how we use linear equations. So you'll notice the objectives here: write and use mathematical models to solve real life problems. So applications, we're using our equations to solve using the information we're given, to solve specific types of problems called mixture problems, and we'll look at an example of that. And then to use common formulas to solve real life problems. So that's like area, principal, temperature, distance, and we'll go through a whole list of those common formulas in your notes. So starting off here just with some background information. We have in this section, you'll use algebra to solve problems that occur in real life. Mathematical modeling, and here's what we talked about, is the process of translating phrases or sentences into algebraic expressions or equations. So taking the information we have in the sentences and converting them into our equations to solve. A good approach to mathematical modeling is to use two stages by starting with a verbal model. And a verbal model is just where you write out in words what it is you need to find. So it's kind of like showing your thinking, putting your thought process down on paper, and then taking those words and applying the numbers and making that algebraic equation. So we do this, but maybe not as explicitly as writing it all down. So that's what we'll look at in these notes. And then there's a little note down here at the bottom that says when you're constructing a verbal model, it's helpful to look for hidden equality, which is a statement that two algebraic expressions are equal to each other. So we want to use the words and pick out what words are telling us that two things might be equal. All right, so let's start with an example. And all of these examples come from the book, and they are matched up with the example. So this is example 1 from the notes in your book. You accept a job with an annual income of $32,300. So that has got to be important. So for the whole year, we make $32,300. This includes your salary and a year-end bonus. So it includes salary and a bonus, and that bonus is $500. You are paid twice a month. What is your gross pay, gross income, which is your pay before they take out the taxes? If you've taken an accounting class or anything, you've seen that terminology. So what is the gross pay for each paycheck? Okay. So basically we want to know how much is each paycheck before taxes are taken out. So we have an annual income. So that's going to be like our total. So I'm going to write some notes here with their verbal model as well. So income, and that's going to equal, right, our salary and the bonus. So our income equals the salary so plus, and I'm trying to use math here, math symbols, plus our bonus. And we know that bonus is $500. Now it doesn't give us a salary, but it tells us we're paid twice a month. So what that means is we have 12 months in a year times 2 if we're paid twice a month. So we're paid 24 times throughout the whole year. So in order to get our salary, that salary is going to be the amount of each paycheck times how many paychecks we get, which is 24. So notice how their verbal model took the word salary from the original problem and broke it down into the fact that in order to get that salary, we have to figure out how much each paycheck is. And then we know there's 24 of them. So it breaks apart that salary aspect, because then what we are looking for is it's asking for the gross pay before taxes of each paycheck. So we're looking for this piece, the amount of each paycheck right here. So that's where our variable is going to go. So now if we substitute in the information we have, our income for the year, our annual income is $32,300. And then we get 24 paychecks, so that's just going to stay 24. And this amount of each paycheck is what we want to find. So I'm just going to call that X. Plus our bonus, we look over here, we know our bonus was $500. Now we took all of those words and we made it into an equation that's pretty simple to solve. So if we solve this, I'm going to go ahead, I'll just rewrite it as 32,300 equals 24x plus 500. We know then that we would subtract the 500 over to both sides. That leaves us with 31,800 equals 24x, and then divide by 24. And if we calculate that, we'll get an x value of 1,325. So what that means is, let's think about, does this make sense? So we want to find what is the gross pay of each paycheck. So we just said that each paycheck, so I would like you to write out an explanation for these word problems. Word problem, word answer. I'm sure you've heard that before. So each paycheck will be $1,325. And then we do want to say before taxes, because now taxes will get taken out, so the actual paycheck will be a little bit less than that. But that is a reasonable answer. You could substitute that back in, take that times. So if we do a quick check here, if we take that, each paycheck times 24, if we multiply that times 24, it gives us that 31,800. And then if we add on the 500 to that, that gives us our salary of 32,300. So you can always do a quick check, make sure your answers make sense with the problem, make sure everything adds up after you substitute back in. So there's our answer for our first example. And then the last piece of this video here gives some phrases and words to look for when you are interpreting your sentences into an equation. So keywords and phrases that mean equality, that mean addition, subtraction, multiplication, and division. So you can go through and look at equality, equals, equal to, is, are, was, will, be, represents. And then here you've got all your words for addition, sum, plus, increased by, more than, total. Total is a really common word for addition. You see that if you're working with anything money. Subtraction, difference, minus, less than, decreased by, subtracted from, or reduced by. Multiplication, product, multiplied by, twice, times, percent of. If you're working with percents, you can use multiplication. And then division, quotient, divided by a ratio, or per. Per is a common division as well. All right, and then it gives you some descriptions and some examples to look at. So one thing your homework is going to ask you to do is kind of go backwards here. So your homework might give you this expression, 5 plus x, and then it wants you to write using the words that we have here. So like sum increased by, so this could be 5 increased by x. Here it's the sum of 5 and x. So basically, I want you to use any word other than just that plus sign. So if you have any questions on that part of the homework, let me know. Otherwise, there's your first video for lesson 1.3.